Okay, so on question 49, that is not what I wanted. Come on. This. Oh yeah, there's nothing there but some sunglasses. Let's open it up again, since it's looking at the wrong thing. Alright. What is he rambling about now? I know. I had to edit it again, and I uploaded the new one just a few seconds ago. Sorry. Glad you found the textbook link online. Alright, so we got this, we can make our scatter plot. Zoom 9 gets me my cool looking picture. I already got the line going through there, that's nice. Okay, which, StatCalc linreg ended up giving me a 0.948. Is that good? Yeah, that's pretty good. That's positive strong. Okay, now what I notice here is, let me write this down. Maybe I'm writing. What's the slope? Whoa, that's not what I wanted. Let's do that. What's the slope here? 0.825. I can't even write. I'm saying it and I'm not writing it. That's the eraser. I'm supposed to get the eraser. There we go. Okay. I'm going to put over 1 just for fun. Because you need to interpret what that slope is. Let's understand what the data is showing us. Okay, so the data was children's ages in white. So, how are you going to interpret this 0.825? What's the number on the bottom? What does it mean? Come on, Y's over the X's. Rise over the run. Okay, this has to go with X, which would be this over here, right? You got X and you got Y. So, as age increases by 1 month, what happens? Ah, yes. Weight increases by 0.25 pounds. Increases 0.825 pounds. Oh, come on. I didn't do that. Sorry. You need to be able to do that. Yes, if it helps you, put a 1 under there. All right, let's move down to question 51. Because I'm guessing some of you left it blank. Or just copied it off the answer sheet. All right. Did you realize that this right here, initial value 2350, is a coordinate? What coordinate is that? I need an X and a Y value. Initial value. So that means we bought the computer today. How many years have gone by if we bought the computer today? 0. So what's the Y value? The cost. Hopefully you realize it's 2350 today. So that was a coordinate they gave you. Now, yes? Typically we think of things occurring over time. So when you think about time graphs, you put time on the x-axis and then you see what happens when you change to whatever we do. Time many situations. It's a good question. All right. So depreciating, what does that mean? It's going down. If you're in the world of business, you get to depreciate things that you purchase. So evidently, the accountant said, hey, you can depreciate that over 5 years. In other words, you can say that it's worth $0 after 5 years. You might still have the computer might still be doing a good job for you, and you can use it forever, but you can say that it's worth $0. You're writing off value on your taxes. So after 5 years, what's the cost of the computer? It's worth nothing. Okay, that should be enough information to get a linear function out of it, right? So what's the slope? Hopefully we know how to do this, right? 2350 minus 0 over 0 minus 5 equals how much? Well, if it's 470, that means it's going up in value. Negative 470, that is true. Negative 470 over 1. You look like you did everything right. Okay, interpret what this means. For each year, what about the computer's value? The value of the computer goes down by $470. That's the kind of stuff you need to be able to interpret. Each increase in year, okay, so give me the equation. Y equals negative 470x plus what? It really concerns me if you don't look at that coordinate right there and say, hey, that's the y-intercept. At this point, we should be able to look at a coordinate like that and decide that. So, how do we find the answer to their question, the value after 3 years? Plug in 3 for x, and I shall leave that into your perfectly capable hands. Okay, hopefully, if you didn't do that, then you now understand the process. Okay. Any other questions on that before we move on to keep going on the 2 unknowns? Okay. When we last left our superhero, where were we at? I think somewhere in the example 5-ish range. No. We had to do this. Example 4. We gotten through example 3. We're on example 4 now. Okay, so describing these things, man, it would be nice if we could put this thing into a fireproof form. Take a look at it. So what would we do with this thing? Subtract it over. Okay, what about this thing? Divide. Okay. So there are 3 things going on here. Can you tell me what they are? What are the 3 things going on here? There's a vertical shift, right? Going up 3 or down 3? Up 3. Okay, so we move this thing up 3. Alright, what else? There's 2 more things going on. Flexion across the x-axis. Nice job there. The y's. Vertical shrink. So if it's going upside down like this, then the vertical shrink would go whoosh, because it's pulling those y values up towards the x-axis. That's kind of the idea that's going on here, if I'm just giving you a quick description. Of course, since we shifted this thing up 3 units, but, I should use my thick pen with 3 C's. Somewhere in there. Close. Wasn't very exact, but it was close. We know this thing's opening down. You got any other favorite points you want to plug in there? How about a 2? What happens if I plug in a 2? 2 squared. Right here, 2 squared. That's 4. What's 4 times negative a half? Negative 2 plus 3. So 2 gave me a 1. And can we find a third point? Hey, good job. You went to the other side of the axis of symmetry. Nicely done. Yep. Okay, so drop that back and change color. So we got the basic idea. Okay. Slide over to the next one, put it in fireproof form. Sorry for the randomness, folks. Gotta lock it first. I don't know if I can get rid of that dot. It's looking like a lot of work. Come on. Yes! Alright. So, moving on over. We got y, what? Plus 1? Over what? Over 3. And on the other side we got x plus 2 quantity squared. Okay? Where's the vertex on this thing? Negative 2. Alright, where's the vertex? It's at negative 2 what? Not at negative 2, 0. This has a vertical shift. Which way? Up 1 or down 1? Down 1. Right. So, negative 2, negative 1. I want to pick a different color. Negative 2, negative 1. Got ourselves a dot. Okay, so besides that, what's the 3 doing? It's a vertical what? Stretch. Okay, so this thing's going to look tall and skinny and open up. Alright. So pick a number to throw in there. What should we put in there? 0? Want to put 1 in? We could put a 1 in. I thought 0 was nice. Maybe. So if I put a 0 in, what's 0 plus 2 quantity squared? That's 4. 4 times 3. 12 minus 1. 11. Holy cow, that's on my graph almost. So 0. Bonk. Alright. And then, of course, how are we going to find another point on the other side of the axis of symmetry? It's 2 units away, so I come over 2 units and plot myself another one. Wow, this looks good. I know, shake your head at me. I see over there. Basic idea. We're just giving it a nice sketch. All things you should probably already know how to do. Just a little bit of review. Okay, we need to practice this, the completing the square. We talked about the proof of it. We did that whole thing. Some of the problems in the book are nasty. That's why I made the video on number 31. So if you, we'll try to maybe do an ugly one here in a second, maybe 27 or something. And then maybe that'll give you enough help. Okay, so first things first, let's move the 11 out of the way because it's, so we'll sketch that over to the other side. And, oh, come on, folks. I threw that in there for you. Wasted. Okay. We need to figure out what to add to both sides. And what was that cool fraction I told you we would use? B squared over what? 4a. All right. The key to all completing the square, in my opinion. So b squared over 4 times a. Anybody know what that is? Now we could say 144 over 12, or we could realize that we have 12 times 12 over 12. Anything cancel out? How about a 12? Okay, so the answer to the magical question was 12, and if you add a 12 there, of course you're going to add a 12 on the other side, giving me a grand total of how much on the left? Alright, now, out of these, we are going to factor out the coefficient of the squared term. Now, don't say to me, oh, Mr. Staley, we're going to factor out the greatest common factor. I do realize that that's happening in this example. But that's why questions 27 and 29 and 31 in your homework are ugly, because that number is not a common factor. So this is an easy question compared to those. And yes, you'll have to stick with fractions. So if I pull the 3 out, what am I left with? Remember, we said that factoring is nothing more than dividing. So tell me what we get when we factor out the 3. X squared plus how many x's? 4 x's plus how much? Okay. Now that's kind of special because it's a perfect square. This thing right here is a perfect square. What is it the perfect square of? X plus 2, right, exactly. That's x plus 2 times x plus 2. If you were to factor it, and since they're both the same, we can write it x plus 2 quantity squared. One more thing to get y by itself. Move the 1 over, and so now we have it in what we call vertex form. Vertex form. It's the process of completing the square. Now, you've done this in Algebra 2, and we're doing it now as review. We're going to need it later in the year when we deal with conics. Okay, so we really need to understand that process. Not so much with parabolas as with other things, but we're just doing it a lot as review right here. This is all the same old stuff we've talked about before, so vertex form, pretty generic. All that stuff is should be familiar to you. A causes it to open up or down. H and K are your vertical and horizontal shifts. Of course, you should all be familiar with the quadratic formula, since it was given to you at birth. At least you should know it, because we've done a lot with it over the years. So, finding the vertex and the axis of a quadratic function. In other words, they're asking for the axis of symmetry. That would be the axis of symmetry. I'll abbreviate it AOS. Hopefully that makes sense. Axis of symmetry. You've probably heard that term in your Algebra 2 class. If we practice with completing the square here with this one, it will be extremely easy like the last one. We can do this quickly, hopefully. Move the 5. Don't do that. Move the 5 over to the other side so we'd have y plus 5. I noticed that they tried to trick me by rewriting the quadratic in the linear terms, but I'm not going to fall for that. Hopefully you won't either. And so what is your b squared over 4 times a? B squared over 4 times a. What is it in this case? Close. 36 over negative 12 is negative 3. So you're adding a negative 3 to both sides. What what should we pull out of these three terms? What should we pull out of those three terms? Negative 3. Remember, it's whatever is in front of the squared term. Whatever's in front of the squared term is what you're going to pull out. Okay, folks, we're dividing everything by negative 3. When we divide by negative 3, what's left? X squared minus 2x plus 1. On the other side, we have y plus what? 2. Alright? What does this factor into? What perfect square does it factor into? X minus 1, right? You're looking at that negative 2 and you cut it in half. And one last step to get y by its lonesome. Just subtract the 2. Okay, so that's what you get when you do it with easy numbers. What happens when you get into ugly numbers? Well, I would suggest, I want to make sure I get through the other notes first, but I made that video on 31. You can follow along, and I show you exactly what to do in that video. So I would suggest you watch that one to help you with it, so that if you try this process with fractions, you have a guide. So watch that first before you get frustrated with it. Okay, predicting maximum revenue. This model came from example 3, and Y is the price per box, and they want to know revenue. Well, if you want to know revenue, you take the price per box and you multiply by the number of boxes sold, which is, so basically revenue is going to be found by multiplying X and Y together, so to speak. Well, if you do that, basically you're changing this equation into what? If you multiply this by X. Come on, folks, think. What do you get when you multiply that by X? You get a quadratic, don't you? Get a quadratic if we're trying to find the revenue. Okay. Maybe we should use the letter R for revenue instead of Y. That might get a touch confusing. You might need your graphing calculator. Because you are, in order to find the revenue, anytime you want to find revenue, you have to take a price and multiply by the number that are sold. Y, in the case of example 3, was the price, and X was the boxes sold. So if I want to take price and multiply, so you're basically multiplying X and Y together to get that revenue. So you will need to graph this. Problem is, you're not going to have a nice window, so we have to kind of think about this window. What should we be using for x's? What did they use back in example 3? Zoom stat won't do it because you're graphing an equation and not a set of statistics. Okay? So maybe looking at the data might help. I don't know. Let's try. So 0 to, let's say, 5 for x. 0 to 5 for obviously 0 for the y up to, what do you think? Let's go with 80,000 and see if that's even close. Oh, that was so close. Alright, let's try 100,000. This is why I like Desmos a whole lot better, because I don't have to do all this guessing and changing. I can just shrink and stretch it the way I want to. Okay, so we got this this beautiful looking arch, right? How do we find the maximum revenue? Where do you find that at on this parabola? At the vertex, do you know how to find the vertex using this machine? A couple different ways you could do it, but do you have any ideas? How do we find that spot at the top? Hey, we could do the calculate maximum feature. So use your, that's it. That's probably the easiest way to do it right there. Calculate maximum, because then you can just let it do the work for you. So, what did you find out with our cool graph? Looked at the data back here, so that's why I went back and looked at the data, because in order to get revenue, I had to multiply these two things together. So if you multiply those two things together, you know you're getting close to 80,000 right there. That's why I guessed 80,000, and I was wrong. It went even higher than that. So that's why I changed it to 100,000. It's because I was trying to guess my way to get there. But yes, I had to kind of estimate based on what I know about revenue. Okay, did you have the right equation too? Okay, so what did we find for the maximum? I had a second ago and I lost it. How much should we charge? $1 million a box? That would be a little bit outrageous. I'm not sure if many people are going to buy that cereal, but okay. I'm seeing $2.39 or maybe $2.40. We'll round it to $2.40. Yep. We did the calculate here. I'll switch it over to this screen. Do you have that on your screen? Okay. So the suggestion I was given was to use the calculate maximum feature. So second calc, and then which is right above your trace button, and then you would. It's asking me for a left bound, so as long as I get on the left side, I can hit the enter button. Then it's asking me for a right bound. As long as I get on the right side, I can hit the enter button. It's asking for a guess. That guess feature is only used if you have more than one. But just for kicks and giggles, if you want to get it close to the top, that's fine, because that's what I would do if I had more than one. Wow, you can't see that at all, can you? All right, it's just that blinding light. Daggone it. All right, that's better. So when I do that and hit the enter button, it goes to the top and says $2.40 and about $88,226.73. Okay, now ask your question. No? Okay, did you change your window like we described from 0 to 5 and from 0 to 100,000? Okay, then I would go back and change it. So go to window and reset it. Okay, the only way you're going to know what it is to look at the data. I mean, if you look at the price per box of cereal, I mean, okay, but look at the price of the box per cereal. I mean, I knew that $5 would be I knew that that's on the high side of the box per cereal, right? And I knew 0 is the lowest. You can't charge less than $0. So I looked at the data, and then I realized that revenue was found by multiplying these together. So I estimated 80,000, and that's where I was wrong, and I needed to go higher, because when I graphed it the first time, 80,000 got cut off right about there, and I knew I had to bump it up even higher. I wish we could use Desmos because of the whole dragging thing. You can make our window real quick. I wish we could get away from this old style technology, in my opinion, because I think that we have better tools out there. But I can't get away from it. If I could, I would. Okay, this particular equation is another example of a parabola, another quadratic. It is not something you need to memorize. You need to understand the pieces, but you do not need to memorize it. Now, do you understand when you look at this that it's opening down? Okay, when we start thinking about these gravity problems and they're launching objects up in the air. Now, folks, that's not the flight path of the object. It's the relationship between time and height. We could throw this thing straight up and have it come straight down, and we would get the same looking picture. But right here is what they call the initial height. So sometimes in physics they use h sub I, and typically we don't use s. We use like h sub o or h sub I for initial height. We don't use, I know that in calculus they use s for position, but typically just to kind of make things simple, we talk about height. G stands for gravity. There are two different constants for gravity. Yes, physics people, I know that the more exact value is 9.81. I see you. I hear you. I know you're going to say that to me. V sub 0 is the initial velocity. You're going to get story problems where you just have to plug information in and see what happens. It's basically, can you find the vertex of a parabola? We'll talk more tomorrow about that. Keep working on homework questions.